Hey everybody, it's your boy Chase, and today we're going to be learning how to complete the square. And the type of question that this would pop up in is something like this, where they either tell you to explicitly use the method completing the square, or if they just give you a weird looking quadratic that you can't solve using factoring. Basically, the alternate title of this video could have been how to solve any quadratic your teacher ever gives you. So it's kind of important, and we're going to build it up from the ground up so you absolutely understand where it's coming from instead of just knowing a formula. So the first thing I want to do is let's go back and look at the first types of quadratics that you learn. These are really simple things. You know the deal. It's like you have something on one side that you multiply, and then you see if those two things you multiply add to give you the middle thing. It'll become more clear when I start actually typing. So these are easy to solve quadratics. Quadratics. Yeah, there we go. Put a little underline on that so it looks fancy. So the type of thing I'm talking about is way back when you first learned how to factor and solve quadratics, you would get things like this, where it's like x squared plus 12x is equal, no, it's not equal to anything. It's plus 36 is equal to 0. First thing you learned is, okay, 36 times 1 is 36. What multiplies to give 36 and adds to give 12, the middle term? We all know that that's 6, so the next thing you would write would be this. That factors to be this. And I want to add one more step. Those of you who already know what squaring is, it's squaring binomials, maybe you've seen that video. You can go ahead and write this to further simplify what you're trying to write. Another example, another easy to solve quadratic would be x squared plus 18x plus 81 is equal to 0. So what multiplies to give 81 and adds to give 18? 9 does, right? So you got two of these guys, and I'm going to go ahead and rewrite it as a square. There's a lot of things to do with squares in this concept, obviously. So just the last example, I think some of you might be able to see where I'm going with this, but just to drive it home, I want to write this one too. Actually, let me make sure I'm leaving myself space. I'm not. Okay. Let me write this slightly further down because we're going to do something here. One last easy example. In this case, what multiplies to give 4 and adds to give 4? It's both 2. So I'm going to go ahead and just rewrite the final step. So these are easy to solve quadratics. And what I want you to notice is a pattern among these. So this first one, I could rewrite it as 2 times 6 times x plus 6 times 6, right? Because it's really just what multiplies to give 36 and adds to give 12. Well, it's 6 times 6 is 36, and 2 times 6 is 12. So 6 seems to be popping up a lot. And here, that number is going to be 9. Here, it's 2 times 9 in the middle, plus 9 times 9 on the outside. And finally, this one is 2 times 2 here, and then also 2 times 2 here. So the pattern that we're noticing here is very important to understand completing the square. So I'm going to write, in general, easy to solve quadratics. Quadratics is a hard word to spell. Have the following form. Easy to solve quadratics are always going to look something like this, where you have some number a, and the quadratic looks like this. X squared plus 2 times a x plus a squared is equal to 0. Here a is 6, here a is 9, here a is 2. Easy to solve quadratics that are just nice like this, they always look like this, where a is some number. And then if I wanted to talk about the square in general, I could write that something that looks like this is always going to look like this when you distribute. So this is equal to this. These are easy to solve quadratics. But of course, This is not an easy to solve quadratic. So what the heck am I talking about, and where is this going? Well, I mean, it is going somewhere. The video doesn't just end here. I'm going to write, what about harder? I guess I'm using quotations, so I should be consistent with that. Harder to solve quadratic. That T, man, it always slips in. Okay. What about harder to solve quadratics? So, let me give myself a little bit more space here. A lot of math about to go down here. Not too much, a manageable amount. So, what about harder to solve quadratics? Let's look at our example from above. Let me make sure I'm writing the right numbers. Yeah, it's 20x. 20x plus 40 is equal to 0. So, this isn't factorable, right? And it's not an easy to solve quadratic. So what the heck are we going to do? Well, it'd be nice if we had one of these easy to solve quadratics, right? I mean, that'd be pretty convenient. Luckily, what we're going to do is be able to force this into an easy to solve quadratic, essentially, using some neat little tricks. And that's what completing the square is. It's forcing harder to solve quadratics into forcing them to be easier to solve quadratics. What that means is we want this to look like an easy to solve quadratic. The first thing I'm going to do is, well, easy to solve quadratic doesn't have this 40. 40 is not the square of anything. So I'm going to move it over here, leave a little space here. Next thing I'm going to do is notice that there's an x missing here. But then also notice that there's no a in my quadratic yet. So I'm going to add the a squared to both sides. We're just trying to get this harder to solve one to look like the easier to solve one. Well, here we hit kind of a roadblock, right? Now we're not really sure where to go. This side almost looks like this. They're close, but we got this 20 is kind of messing things up. Well, I want this 20 to be equal to 2a. And that would happen when a is equal to 10. Because you divide 20 by 2, right? So it looks like in order for this to be an easier to solve quadratic, we should let a be 10. And what happens next is cool. So if you plug in 10 for a, you get 100 here, right? And you get 100 over here too. Give myself a little bit more space. There we go. Now, this side is an easy to solve quadratic, right? Where a is 10. You got 2 times 10 here is 20. And then 10 squared is 100. So, just so you really understand what's going on, I don't have to do this, but I'm going to rewrite it as this, where you would distribute it out. Now, let's go ahead and solve this side too. 100 minus 40 is 60. They're just written in a different order. And then I can write this, right? Because it's an easy to solve quadratic. Now, from here, we can actually solve the quadratic because we have a something squared over on this side and then just a number on this side. So what we can do is, that's not a 10. This is a 10. That was like an L0. We can take the square root of 60, plus or minus the square root. You got to do that because you're just dealing. It's an equation, so you always have to do the plus or minus when you're taking the square root of things. And then we just move the 10 over. Again, another L0. I don't know what that is. So we get negative 10 plus or minus the square root of 60. And that's our final answer. And that's how you would solve a harder to solve binomial. And basically, what we just did, not basically, we just completed the square. That is completing the square. This whole process of moving it over and then adding a squared to both sides and finding a. You probably learned about the formula, like it's like b over 2 squared. That's where this is coming from. If b is the middle thing, you divide it by 2 and then you square it, and then that's what your a is. I think what I've shown here is slightly easier to understand because we're taking something we know, easy to solve binomials, and then building that into harder to solve binomials. I'm going to give you another slightly harder example so you can get a better grasp for what's going on. If you're ever not really clear on a math concept, and just do tons of examples. Another, I don't know if there should be a comma there, I'm not an English major. Another harder example, I'm leaving the comma there. Sorry if that bugs any English people that have to watch this video. So the next example, well, final example is, let's get a little 4x squared action in here, another 4x, and then minus 3 is equal to 0. So, completing the square, you want a harder to solve binomial to look like an easy to solve binomial. And you can use the properties of the easy to solve binomial to just, okay, the last couple times I said binomial, I meant quadratic. They're the easy words to get mixed up. But this is a quadratic, we want this harder one to look like an easier one. First thing I'm going to do, move this 3 over, because it's not an a squared. It doesn't look like an easy to solve. Then what I want to do is add an a squared to both sides. Actually, no, my bad. You'll also notice that an easy to solve binomial, quadratic, doesn't have a constant here. It doesn't have anything in front of the x. So the first thing we got to do is get rid of the constant. If there's ever a constant in front of the x and you're completing the square, you got to get rid of this. So what I'm going to do is divide everything by 4. This 4 divided by 4 is 1. And you get negative 3/4. 0 divided by anything is 0. So now this is looking pretty good. We can move this 3/4 over here and add an a squared, add an a squared. Well, there's a little imaginary 1 here, right? So we want 1 to be equal to 2a. Well, that would mean a would have to be 1/2. So we got our a. And let's just plug that back in. What's a half squared? It's a fourth is equal to 3/4 plus a fourth. Well, this side's going to work out nicely, but you're not really sure how to factor this, or yeah, I think it's factoring. No, distributing? Yeah, no, you're factoring. You're factoring a quadratic. But look, even though this is hard to solve, we already have this property. Look, anytime we have an easy to solve quadratic, we can rewrite it as this with a. We've found a already, so I can just go ahead and write x plus a half squared. And this side works out nicely. This is 1. Take the plus or minus square root of 1. Square root of 1 is 1, so we're just left with plus or minus 1. And then you get negative 1/2 plus or minus 1. And these would be the roots to this quadratic. So we've taken something that looks like pretty difficult to solve, and we've used our knowledge of easy to solve quadratics to force it into an easy to solve quadratic and then solve from there. So this is completing the square. I encourage you to understand conceptually what's going on, what we're doing while we complete the square, and then once you've got that down, just go ahead and memorize the formula, and don't use up that brain power on thinking through this every single time. But before you do the formula, make sure and understand where it's coming from and why completing the square is so powerful. Because this could work on any quadratic, which is pretty cool. Like, there's an infinite amount of quadratics, and you could solve them all if you had an infinite amount of time, which I think is neat. So thank you for watching. I hope this was helpful.